Okay, I think we are set.
Yes.
Okay, yesterday we started with Revit structures, and I want to go over what we did yesterday and then continue quick one so that we continue from there. Please take note, whenever you are working on any project, the architecture file is supposed to be different. Structures file will be different. If the project is very complex, the mechanical file will be different, electrical file will be different, plumbing file will be different, site file will be different. And then you then merge all of them together using Revit links. And so that is the same approach that I'm going to use to teach all of us here. So that you get that mindset. But for now, we are only looking at how to create Revit structural elements. So we are going through them. When we go through them, then we are done. Then you start a structural project and then link the architectural building that we are working on already, and then do a separate file for the Revit of it and the structures of it. So I'll open yesterday's file, which started with Revit structures. Okay, that's yesterday's file that we started with. Then I'll save it. So I'll go to file.
Sir, please, you can't see the screen.
You can see my screen. Okay.
Yeah.
And let me share my screen. You cannot see my screen.
Yes, sir.
You can see it. So I'll go to file, save as, project. So Revit Essential Training, this will be lesson 9. Save. For now, all of us are very, very comfortable with creating levels. So I am not going to repeat creating levels again because we are okay. Now, when I go to the elevations, one of the elevations, I have my ground floor level, foundation level, ground level, and then roof level. If I should increase the scale small to about 1 is 50, you can see the levels clearly. Foundation level, ground floor level, the roof level. Please, whether you are creating an architectural project, a structural project, mechanical, electrical, plumbing, you would always create what? Levels. Because every element that you are going to create must be related to a what? A level. Without a level, you cannot create any element. So right now we have only 4 levels, and mostly projects that involve structures are not just a single story building. They are usually multi-story structures that involves structural drawings. But because I'm teaching, I'm still going to use a single story building to do the demonstration. Later on, as we progress, we will add more details to whatever we are trying to do. So we have levels already. So I can create a structural element at the foundation level. I can create a structural element at the ground level. And I can create a structural element at the roof level or at the ground floor level. So it depends. Now, when it comes to structural elements too, when I come to the ground floor level, one thing that is very critical for any structural element is what we call structural grade. Structural grade. When you have structural grade, most of the Revit structural elements will be constrained to the grid, so that when a grid moves, the structural element will move with the grid. Yesterday, we looked at some few things. We looked at columns, we looked at beams, we looked at beam system. Those are the three elements we looked at for structures. There are structural walls. We've already discussed walls. That is why I did not bring it about. But structural walls are the same as architectural wall. It also has a base constraint, a top constraint. You can edit the wall type and then give them properties. But the only difference between an architectural wall and a structural wall is that with the structural wall, you can add structural reinforcement to it. But when it is an architectural wall, you cannot add structural reinforcement. But apart from that, they are all walls. If you take floors also, we've discussed floors in architecture. We can also create floors in structures. And if you want to create floors in structures, the same way that we draw a polyline or a closed polygon to create a floor, the same way in structures, you can create a closed polygon to create a structural floor. And with that structural floor also, you can add reinforcement to it. And that's the only difference. Apart from that, all of them are what? Floors. The process of creating them are all what? The same. Any questions so far before I add on? Nico, do you have a question?
I don't have a question now.
Okay. Mr. Dixon.
Yes, sir.
Do you have any question or any suggestion?
No, please.
Okay. Ni,
Yes, sir.
do you have any question or suggestion?
No, sir.
I hope today you are using your laptop and not your phone.
I'm trying to do something.
Are you using the laptop or you are using the phone?
I'm using the laptop, but when it comes, it cuts. When it comes, it cuts.
You will get there. It's normal. You see, normally when you are doing anything for the first time, it's always difficult. But with persistence and commitment, we shall always what? Overcome. Okay?
Thank you.
So let's start for today. I'm going to delete all the structural elements and leave only the grade, because at least we are comfortable with creating levels and grades. So I'll take the beam system and then delete it. I will reveal any hidden elements. I want to reveal any hidden elements and see if there are columns. I think I created some columns. Good. So I'll select all the columns also, select all instances in the entire project, and then delete them also, so that I'll be left with only the grid and then the what? The levels. The levels are datum elements. The grids are also what? Datum elements. So let me go to ground floor level first. I have my grid 1, 2, 8. 1, 2, C, D, E, F. It cannot be 1, 2, C, D, F. So I'll update them. 1, 2, 3, 4, 5. They should be consistent, and then 6. Then here is A, and B. So at least I have some few grades here. Now, any structural element that I create must be constrained to a grade, so that when you update the grade, the structural element will automatically be updated. Apart from it being constrained to a grade, any structural element that you also create must be constrained to a level, so that when the level moves, the structural component will move. So I'll go to the ground floor level and then start with columns. When you create a column is a linear element or a point element that has a height. Normally, when you are creating a column, you must know the level on which the column is starting from, and then the level on which the column is what? Terminating. Usually, a column starts from one floor and then ends at another floor. If you go to any typical construction site, you cannot erect a column that spans from ground floor to the 8th column, to the 8th floor. We do them piece by piece. Even if it is an isolated column that spans 4 floors and you are even casting it, you cannot cast all the column for the 4 floors simultaneously. You cast one floor for it to dry, then you cast the next floor for it to dry, then you cast the next floor for it to dry. So ideally, when you are working with columns, span it between associated what? Level. So I'll go to structure menu, then I'll pick column. Now let me activate my magnifier glass so that you can appreciate what I'm trying to do. So I'll click on magnifier and then expand it to about 200%. So when I go to the menu here, we have the structure menu here. And if you go to the structure elements, we have beam, walls, columns, floors, trusses, brace, beam systems. Connections comes in after you have created the structural elements. Foundation comes in after you have created either a column or a wall before you can apply a foundation. You can also create a foundation slab, and that one too, it must also be related to any of these structural elements here. When it comes to reinforcement like rebar, area, path, fabric, there must be an existing concrete element, concrete structural element. Let's say a column, they can add a rebar, or a slab, they can add a rebar, or a stairs, then you can add a rebar. So if there is no structural component in place, you cannot place a rebar. So for now, our concern currently is to know how to create a beam, a wall, a column, a floor, a truss, a brace, and then a beam system. Already, we know how to create a wall. We also know how to create a floor. The process is the same. So which means that what we need to know to create now is how to work with a beam, a column, a truss, a brace, and then a beam system. Yesterday, we looked at how to create a column, how to create a beam system, and then how to create a beam. So I'm going to go over all of them again. So I'll pick the column first. As soon as you click on the column, watch the options bar. The options bar, it says that modify or place structural column. Rotate after placement. You can define the depth of the column or the height of the column. For now, I'll choose the height of the column. And if you choose the height, depending upon the floor on which you find yourself, you can define the height. Currently, I'm on the ground floor. So the height of my column should be a level that is above the ground floor. And in this case, foundation level is below ground floor. Ground level is below ground floor. Only the roof level is above ground floor. So I'll select a roof level. That is where my column will be. Now, when it comes to the placement of the column, I know it is starting from the ground floor and then ending on the roof level. When I want to place the column, I can place it manually anywhere. So I can click here and place the column. My column is placed. But ideally, we place column at the intersection of grades. So when I come to the intersection of this grade and that grade, I can place this column here. When I come to the intersection of grade A and grade 1, I can also place this column here. But if I know I am going to place so many columns at the intersection of so many grid lines, then I can take this shortcut, place the column at grids. That is where the grid intersects. So when I activate that one, it is saying that place structural columns at grid intersection. So any place where two grid lines are intersecting, I can select all the grids. And when I select them, as soon as a column is a place where the grids are intersecting, the column will be automatically placed at those positions. I can then choose finish. There might be a case whereby you might not need column on all the intersections, but you can use it and then place all of them. Then when you finish, at the locations where you know that you don't need the columns, you can pick them and then delete them. You can pick them and then delete them, just to save you some time. But at the end of the day, what is important is that when you select any column, Revit will tell you from the properties the column location mark. That is the two grids on which the column is placed. In this case, the column that I selected is placed between the grid B and then grid what? Grid 3. As you can see here, this is grid B, and then this is grid what? Grid 3. So B3 will define this column. If I come in here and then I select this column here, it will be A and then 4. That will show me the position of this what? Column. So when I select this column and I go to the properties, I know that it is located at the location what? A4. Any question? It's a column. One thing I'm saying that it's a column. I've not stated whether it is a concrete column, whether it is a steel column, whether it is a wooden column. We will look at that one when we are discussing the types. But the most important thing is that it's a column. Any column, provided it is a column, must satisfy this condition. You can place it at the intersection of grids, 1. And then 2, the column must have a base constraint and then a top constraint. So when I select this column and I go to the properties, the base level is ground floor level. That's the base level constraint. And then the top level constraint is also what? Roof level. So that when I go to the 3D view, I'll see my columns here, starting from the base to the top. My columns are not showing. Maybe they are hidden in view. So I'll go to reveal hidden elements. That is the ball bear. And when I click on that one, I should see my columns. I'll right click, select all instances in entire projects. Okay, then I'll go to unhide category. When I go to unhide category, I can close it, then I can see all my columns. And all the columns are starting from the ground floor level to the roof level. If I go to any of the elevations, let's say north elevation, I'll see that my columns are here. Let me increase the detail level from coarse to say fine. Now if I go that, I'll see that my column is here and it is starting from this level here, which is ground floor level and terminating at what? Roof level. Any question, please? Any question? The way everybody is silent, it means everybody is okay.
Yeah, I think I'm okay. Yeah.
Okay.
I understand what you're saying.
Okay.
I'm also fine.
You're also fine.
Yeah.
So I can go on to the next item.
Yeah.
Now let's look at
Yeah.
beam. A beam is also a linear element. only that it is not a point reference. A beam is rather a line segment. When you take a beam is a line segment. It has a start point and then an end point. So you must know where the beam is starting and where the beam is what? Ending. Please understand how to create just a single beam. Just a single beam. Then later on you can add another beam and then get 2 beams. Another beam and then get 3 beams. So if your building is a simple building, a rectangular shaped building, then you have just about 4 beams. If your building is more complex, then you have more what? More beams. Please, let's look at beams from the basic construction level. When we did construction in university first year, we were taught about the post and beam method. So you have the column, 1 post here, then another column, 1 post here. Then if you want to add a beam, you add it from the top of this column to this column here. Okay. And you can start it from this column here to that column as a linear element. You can start from here to here as a linear element. So when you click on beam, you should also know that a beam is a linear element. It can be a wooden beam. It can be a column beam, a concrete beam. It can be a steel beam. It can be a lattice beam. It can be any beam. When you were going to your school to go and learn your building construction or architecture or structures, I wasn't there. You know the kind of beams you learned whilst you are in school. You know the kind of beams you are comfortable dealing with them. Try to understand beam the way you understand beam. So when I want to create a beam from the Revit perspective, I can draw a beam from here to there. This one gives me a beam. It's a linear element. I can also draw a beam from here to here. It's another linear element. It's a beam. But ideally, we don't draw beam in isolation. To coordinate your project very well, you must constrain your beam to grids. You must constrain your beams to grids so that when the grid changes, the beam will automatically what? Change. So for instance, I'll take this beam, right click, create similar. And when I'm drawing my beam is on the foundation level. If you look at the properties here and you look at the level here, constraint, it's currently on the foundation. So I can change it to ground floor, I can change it to roof level, I can change it to but for now I'll maintain it at the foundation. Then I'll come in here and then start to draw my beam. So I'll start from this corner here and then end at this corner here. So what it means is that my beam is constrained between the grade 1 and then grade 2. And then on this particular grade, which is grade what? Grade A. So the beam is on grade A, but it's starting from grade 1 to grade what? Grade 2. When I select the beam and I go to the properties here, you know that the beam is on a reference level foundation. The work plane is on level foundation. Start level offset is 0. End level offset is 0. Cross section is 0 degrees. For now, that's what I want to do. This geometry position, materials, structural properties, dimension properties, identity data, facing, IFC parameters, we will look at all of them later on. But if you cannot create it, you cannot understand these things. So what we are interested in now, currently, is to understand the constraint condition of the beam. Currently, the beam is on the foundation level here. And if you look at the foundation level, it is faded out. You can't click it, you can't change it, you can't do anything. So which means that if I want to move the beam from the foundation level to, let's say, ground floor level or to the roof level, I cannot easily change it here in the properties palette, which means that there should be another way that I can use to change it. We will look at it later on. But it's here. We go here, it's called the edit work plane. If you go to the edit work plane, you can choose edit work plane, and then a dialog box will pop up. Then you know that it is on the foundation level. Then you can change it from the foundation level to a different level. So currently it's on the foundation level. If I change it to the ground floor level, and I select the ground floor level here, and I go to OK, the beam will automatically move to the word ground floor level by moving away from the word foundation level. As simple as that. Any question? For beam. Before I draw another one. Gary.
Okay.
Are you okay with the beam?
Okay.
Yes, sir. Are you okay with
Yes,
the beam?
carry on, sir.
Okay. Joshua.
Yes, I'm fine.
Joshua. Joshua. Dixon.
Yes, sir.
Are you okay with the beam?
Sure.
Good. But just like we did for the columns also, if you want to create multiple beams on grids, you can do that. You can select the grids on which you want to put the beams. Then you must specify the level on which you want to put the beams. So I can go to beam again. And when I go to beam, I'll go to on grids. But in 3D view, the on grids is inactive. So I'll go to the level on which I want to create the beam. In this case, I want to create a beam on the roof level. So I'll open the roof level. Then I'll activate my beam. Because I'm on the roof level and I'm creating a beam, it will automatically place at the what? Roof level. I want it on grids. Then I'll select all the grids, every grid. So that now that I've selected all the grids and I go to finish, my beams will be connected between all the grids at the roof what? Level. As simple as that. Because there wasn't any member here, it connected it straight away. But because there's a column here, it placed it in what? In between them. And that is how we create the beams. If I want the beams on the ground level, I can select all the beams, select all instances, visible in view. I don't want these two to be part of it, so I'll use control to deselect them. Now all these beams are now selected. So I can go to clipboard, copy to clipboard. Then all the beams will be copied to clipboard. I can then go to paste drop down and then choose paste align to selected levels. If I say paste align to selected levels, I can decide to paste it on the foundation level. I can also decide to paste it on the ground floor level, and I can also decide to paste it on the ground level. But for now, I don't want it on the ground level. I don't want it on the foundation level. I only want it on the ground floor level. So I'll go to shift, deselect ground level, then use control only to select what? Ground floor level. When I choose OK, all the beams will be copied to the ground floor level for me. Just as I've copied the beams to the ground floor level, I can also equally, let me delete these ones, I don't need them for now. I can also equally select the columns, all the columns. When I want to select all the columns, I can right click, select all instances in entire project or visible in view in entire project. All the columns will be selected and the columns are on the ground floor. They are terminating at the roof level. I can copy it to clipboard. When it is copied, I can go to paste, align to selected levels. Then I want to paste it, align to the foundation level. Then all my columns will be pasted on the foundation level. When it is pasted on the foundation levels, while it is still selected, I can come to the properties. I pasted it on the foundation level. The base offset is -3150. No, I want the base offset to be 0. The top level is foundation level. No, I want the top level to be on the ground floor level. So I'll choose the ground floor level. So that the top floor will be on the ground floor level. The base will be on the foundation level. Base offset at the foundation level should be 0. Base offset at the ground floor level should be 0. When I'm finished, I'll get my beams starting from the foundation up to the ground floor level. So I've created my beams, I've created my ground beams, I've created my roof beams, then I've created all my columns, foundation columns, and then ground floor columns. Any question? If I go to the floor plans, yes sir.
Please, I'll be glad you go over it again because you were like you were speeding.
I was speeding. Oh, we did it.
Yes,
We did it yesterday. Okay, so let me go over again.
Oh no, regarding the foundation, because I saw something, you copied something and you pasted somewhere.
Yes, I did copy to clipboard. Okay.
Yeah.
So I'll go to Control Z. Okay. So currently, I have beams on the ground floor. So these one are the ground floor beams. So if I go here, go to the front, and I draw a window around it this way, okay, and I go to the isometric view like this one, you see that I've selected only the what? Ground floor beams. I deselected, select previous. These are the ground floor beams. Do you see them? Now I've selected them. And all of them are on the ground floor. I can decide to copy it from the ground floor and then paste it on the foundation level. So I can choose copy to clipboard, and it's copied. There's the copy to clipboard here. When I click on it, where's the magnifier? Let me increase the magnifier. There's a copy to clipboard here. If you want to cut, you can cut, but I don't want to cut, I just want to copy. When you click on it, it is copy to clipboard. Now when you go to the paste drop down, you can paste from clipboard, you can paste align to selected levels. Please, pasting align to selected levels, you are going to use it regularly to speed up your work. Then you have paste align to same place, but I want to paste align to selected levels. So the selected levels, a dialog box will pop up for me to choose the selected level on which I want to paste it. So I can decide to paste the beams on the foundation what? Levels. So when I select the foundation level and I click, yes sir. Then I go to OK. You go mute your mic. Please mute your mic. Oh, mute your mic. So I go to OK. When I go to OK, you see that a copy will be made to the foundation level. Please, I need to. Okay, do you understand it now? Are you okay?
Yes, sir.
Yeah.
Yes,
So
sir.
just as I copied the beams to this level, I can also copy the columns from the ground floor level to the foundation level. So I can select just one. I can use Control and select 2, or I can select more. So if I want to select all of them, I can right click, select all instances, visible in view. Then all the columns are selected. So if I want to select all of them and then place them on the foundation level, I'll go back again to copy to clipboard again. Then to make a copy. Then when I choose the paste, align to selected levels, then this dialog box will pop up. Then I'll choose the level on which I want to paste it. So if you are doing a multi-story structure, let's say you've gotten some hostel project you are working on, and then the hostel project is say about 4 stories or about 6 stories, then you have to take your time and then model the columns on one floor, model the beams on one floor. Then when you are done, you can copy them and then paste them on the subsequent floors. And if there's the need for you to edit some of them, then you can take your time and edit some of them just to speed up the work. So now I can say that I want to paste it on the foundation level. Then I go to OK. Then the copy will be placed on the foundation level. But when it was placed, you realize that it is not starting from where I'm expecting it to start, and it is not terminating where I'm expecting it to terminate. But I will not deselect it. While it is still selected, I'll go to the project browser and make sure that it starts from the foundation level and then ends on the top level, which is supposed to be ground floor level. But I want the base offset at the foundation level to be 0. Then I want the top offset of the ground floor level also to be 0. So when I'm done, you see it will be placed properly at where they are supposed to be. Are you okay?
Yes, please.
Now, the next thing that will concern us little about beams is that we can create the beams, all right, but we must decide whether this column is going to be a concrete column, or it's going to be a wooden column, or it's going to be a steel column. Even if it's a steel, is it going to be solid steel? Is it going to be hollow steel? Even if it is a hollow steel, is it going to be galvanized pipe, or is it going to be iron or... Those are the design decisions. It has very little to do with Revit. What Revit is more interested in is that you know the kind of beam or the kind of column or the kind of whatever you want to create. Then you should be able to do whatever you want to do with whatever you want to do with it. Are you okay? We are good?
Yes, sir.
Thank you, sir. So we are okay with the beams. So now I'm assuming that you can also create beams. So the next time I'm going to discuss beams again is that I'm going to take the pilot project that we are working on. Then I'm going to draw the beams in that pilot project where they are needed. The next time I'm going to discuss column, I'm going to create columns in the pilot project where they are needed. Now, the next thing we also looked at again was beam system. And what I said was that a beam system is also like a beam. But this time around, it is a beam that are multiple beams that are spaced at regular intervals. So when you want to create a beam system, all you need to be able to do is to sketch some line work. And the line work that you are going to sketch, you are going to use this draw tools here to sketch whatever you want to sketch. And you are going to sketch a closed polygon. So I can draw a polygon from here. I'll pick a line. Then draw a polygon from here to there to here. Go here. Go this way. And then come and close it here. And when I do this one gives me a polygon. When I go to the floor level, let's say ground floor level here, I'll see the sketch here. This is how I drew it. Anybody can draw any building shape, and you can draw the outline of the building shape where you want the beam system to fit. This shape is very awkward. Never mind. I can delete it. Delete this one, and then bring this line here to come and meet this line here, and it will give me a quadrilateral as I've drawn here. This quadrilateral that I've drawn, there is the beam member. The direction of the beam is defined by these two lines here. When I choose finish here, it will create the beam members at regular intervals. This intervals is a formula that you can select and then update. When I select it and I go to the properties, we call it layout rule, and it is saying that it is a fixed distance and the spacing between them is 1828.8. So what that means is that the distance between this and this is 1828.8. If I want it to be a distance of 600 in between them, I can type in 600 and it will get me the spacing between them of what? 600. And I'm saying that especially if you are doing a wooden structure whereby you are going to use a lot of ceiling joists or ceiling wooden members to do it. If you want to create your ceiling in your structure and you want to show your ceiling members, this beam system comes in handy. If you want to create your purlins on the roof, this beam system comes in handy. If you want to create rafters on a roof, this beam system comes in handy. And the direction, when you select the object and you go to edit boundary, it will take you back to the sketch mode. So wherever you want it to be the boundary, you go to beam direction here and click on the beam direction. When you click on it and I select this one, that will form the beam direction. When I finish, all the beam members will go in that direction. If I finish, I'll get it in this direction as you can see. If I edit structure and I want the beam members to follow this path here, then I'll pick beam direction, click here, so that this will be the direction of the members. When I finish, that will be the direction of the beam members. And this is what we call a beam system. You can only get one direction at a time. You cannot get two at a time. So if I need another one, I can select this beam system, copy it to clipboard. When I copy it, it's copied now, it's a copy. Then I can go to paste, align, not to current view, but I want to paste it, align to the same place, align to same place. So it will be pasted at the same place. So now I have two copies. It will give me warning. Then I can go to edit boundary. And when I go to edit boundary, this time around, I don't want the direction to go here, but I want the direction to be on this line. So when I choose beam direction here and then click here, this will be the direction of the beam. The original one, the direction is here. So when I finish, I have two beam systems drawn together. One is going vertical, then one is going what? Horizontal. So if you look at it in 3D, you should see your beam system created, showing you vertical and then horizontal what? Members. And with this system, within just a short period of time, you can create your ceiling joist members. You can use it to create your rafters. You can use it to create your purlins. You can use it to create any structural member that requires repetitive representation of beams. And these beam members here, it can be I-section, it can be concrete, it can be timber, it can be hollow steel, it can be anything. Any question?
Hello, sir.
Yes, sir.
Sir, my question has to do with the columns. As I saw, we created the columns from the ground floor to the roof, and we created another, like we copied it and changed the base constraint to the foundation and the ground floor.
Yes, sir.
Yes. So here you can see that we have a separate column at the sub-basement.
Yes, this is
The separate column at the superstructure and the substructure.
yes, sir.
So, and per what you just taught us, I also know that we can change or we can extend the top one to the foundation to get one column from the foundation to the roof.
Yes, sir.
Per what you just taught us. So I'm just thinking maybe that is what how I understand it per our first tutorials concerning the walls, where we created the foundation wall and the superstructure wall. So that when you are doing calculation for the blocks or something for only the foundation, it will be easier for you to do. So I'm assuming that it's the same thing applying to the columns.
Thank you very much. The same thing.
Okay.
The same concept.
Okay.
So
Okay.
every
Okay.
building component you are creating, normally when we are doing construction, we do it floor by floor. Any construction that
Okay.
you do, first you do the foundation first. When you finish, you
Okay.
do the filling before you cast the ground floor slab. Then you erect.
Okay.
If there are columns, you erect the ground floor columns. If there are walls, you
Yeah.
erect the ground floor walls. When you finish, you add the
Okay.
ground floor beams or first floor beams. So the way we model on construction sites, use the same principle and then concept when you are doing your what?
Okay.
Revit model.
Okay.
So that when you go to the site, you
Okay.
can always differentiate between when you are working on the foundation and when you are working on the what? Superstructure. You see, in our part of the world here, people don't have money. Most people are broke. So when we are building, we don't have the money that I'm going to take 6 months and then finish a 3-bedroom house. No. People can do a foundation first. And when they do the foundation, then they go for another loan from somewhere and they come and do the superstructure. So it is always advisable to, when you are modeling, you have this mindset so that you can model at different sections. So that when you want to face the project, you can face it, the foundation phase, the superstructure phase, the second floor phase, even the block work. Let's do the foundation phase first so that you can always segregate them and manage them properly. But if you just do one column from the foundation all the way to the 3rd floor level, we don't do that on site. Even you won't get an iron rod that you are going to use to do the structural aspect of it, reinforcement of it, from the foundation all the way to the 3rd floor. We still cut the iron rod in pieces, start from the foundation up to the top of some kickers on top. When you finish, then you do the 1st floor columns, you come and insert them. When you finish, you do the 2nd floor columns. Do you understand what I'm saying? So when you are modeling, have that mindset in your mind so that you can manage your project better.
Okay, thank you, sir.
Thank you, boss. Any other issue? So we are okay with beam system also. So now let's look at, so we've looked at beam, we've looked at beam system, we've looked at column. Now the next thing I want us to look at is truss. As for floors, we know how to create floors already. And the walls, we know how to create walls already. It's the same concept. So let's look at truss. To create a truss is also a linear object. Then you have to get a starting point and then the end point. So I'll do it in 3D. When I finish, I'll go to plan. So I'll go to truss. As soon as I go to truss, you see that you can draw it either as a line, 2 points, or you can pick an existing line as a truss. A truss is a line, nothing more, nothing else. So I'll click first point, then I'll click what? Second point. A length of 6,000, then I have my truss. But the question is, where is this truss coming from? This truss is a loadable family, which is loaded. So when you click on this truss here, although it is a linear element, there are different types of what? Trusses that you can load and then work with. In this case, we only have a whole flat truss. That's what is loaded. So if you need a different truss, the only thing you need to do is that you can go and load another truss from the library and then change it to that truss. So let me copy this truss, for instance, to the side. So I'll copy it here. So I have 2 of them. These are 2 trusses. So if I need another truss, the same length. If I need another truss different from this one, then I need to go and load it from a library. So I'll go to insert menu. Let me magnify it. You go to insert menu. When you go to insert, we have load family. So I'll go to load family. Then a dialog box will pop up that I want to work with. Always check the library you are working in. by default it is set to imperial. I don't want that one. I want metric. So I'll go to libraries folder, then choose English. When I choose English, I'll go to say UK folder. Then within the UK folder, I'll go to structural trusses. So this is the structural trusses folder. Then I'll go to open. By default, Revit came with a lot of trusses. Think truss. This is the preview here. I hope you can see the preview. Think with chambered bottom truss. Whole flat truss. Whole gable truss 6 panel. Whole gable truss 8 panel. Whole gable truss 10 panel. Whole gable truss 12 panel. Pratt flat truss. Pratt gable truss 6 panel. Pratt gable truss 8 panel, and so on, all the way to Warren truss 7 panel, Warren truss 9 panel, Warren truss this. Please, I beg, these are sample of trusses that is shipped with the Revit software. As a beginner, you have to explore these trusses and then learn how to use them, when and where to use them. If you go beyond the level of essential Revit user, then you become a master. You might realize that you might want a different truss that is different from the truss that is here. The best thing you can do is to create your own truss. If you cannot design your own truss, then what it means is that you will be limited to these trusses that is shipped with the software. And if you realize that you are only limited to the trusses that is shipped with the software, then it realize that you are handicapped. You are not an advanced Revit user. You are not a master Revit user. So the only thing you come out and say is that Revit is limited. If I want to create such a truss, I cannot find it. There are few trusses. The point I want you to understand is that you can design any truss you want and then work with it. You should condition your mind, you should prepare your mind to get to the level whereby you come to the realization that you don't need any of these trusses, and then you need a different type of trusses. Very soon, I am going to introduce a mastery level training. And if you don't see anything wrong with these default libraries that is shipped with the software, in this case, these libraries that you see here, that is shipped with the software. If you don't feel challenged by them, then it means you are not prepared and ready to do the mastery level of training. This is for essential users. So if you want to be a master, then it means that you must position yourself whereby you can create your own custom word libraries. That is what you should take note of. So if I want a different truss, I'll go to English, I'll go to UK, I'll go to trusses, structural trusses. Then I can take any of these trusses. Let's say this one, 8 panel truss, then I'll go to open. So that truss will now be loaded into the project. So that when I select this truss here, and I go to the type properties, you see that now I have 2 trusses. One is M-hole flat truss, the other is whole gable truss. So when I change it to whole gable truss here, it will change automatically to that truss for me. Watch, you see that it has changed. Now later on, when we look at how to edit the truss, then we look at how to edit the top chord, the bottom chord, the members, how to size them, how to change them, and then you can get it done. So that is about truss. Apart from that, every truss is a linear. So if I take this one and I create similar, it will give me the same truss no matter the length of the line that I draw. When I draw a long line like this one, it will define the same truss as this one. The same number of chords, the same number of diagonal members, the same number of top members. If you count them, they are all what? The same. You cannot use any formula to change it that you want the members to be equally spaced or equally that they are fixed members. And if you want to do a parametric one, I can also assure you, you can create a parametric truss, but it will take us time before we will get there. Any question on trusses? Any question? Yes, sir.
I think if you can go over this one.
I should go over again.
Yeah, with the trusses. Yeah.
Okay. Now, when I come in here with these trusses here, what I'm saying is that a truss is a linear member, nothing more. If I want to create any truss, I can go to the ground floor level or the roof level and then pick structure and then pick truss. When I pick truss, what I'm going to do is that I'm going to draw it as a linear element. It's not curved. Every truss is straight line. So I'll draw from here to here and then specify the length of my truss. In this case, 9,000 length of a truss. When I'm finished, the truss is drawn. If I select it, it is a truss. If I go to 3D and I look at it, this is it. It is this truss. But this truss, somebody designed it and then gave it a name. And the name the person gave it is whole gable truss 8 panel. So which means that it is 8 panel truss. If you count it, 1, 2, 3, 4, 5, 6, 7, 8 panels. That defines the truss. And it is only that. No matter the length, how long, how short it is this type of truss. If I need a different truss design, then I must go and load another truss, which has a design different from this one. So for instance, I can copy this truss and bring it forward this way. Okay, then I can go to insert, load family, and when I go to load family, I'll go to my structural trusses and then take a different truss. Let's say this one, scissors truss 8 panel. Then I go to open. Then it will also load scissors truss 8 panel. It is also a linear element. So when I select this truss, I can go to the type properties and then change it from whole gable truss 8 panel to scissors truss standard 8 panel. So it will give me this design also, which is a scissors truss. As simple as that. If you need any truss that the design is different, then you must be able to design your truss. If you cannot design the truss, then what that means is that you must rely upon the trusses that is shipped with the software. And if you position yourself in a manner that you will only be limited to using the trusses that is shipped with the software. If you position yourself that will be limited to be using only the windows that is shipped with the software. If you limit yourself to be using the water closets that is shipped with the software, then it means that you are swimming in the children's swimming pool of Revit. Let me repeat again. All the default content that is shipped with the software, they are samples of files that AutoCAD add to the Revit. Oh, you can get a swimming pool like this one. You can get a water closet like this one. You can get a shower like this one. You can get a door like this one. You can get a 3-bay window. You can get a 2-bay window. If you look into the Autodesk Revit libraries, for instance, I have never seen a 4-bay window. So if you are doing a design, then you are supposed to, for instance, use a 4-bay window. And you go through the libraries and you don't find a 4-bay window. Oh, Charlie, Revit requires 4-bay window, so Revit is not a good software. No. There are tools in Revit that you can use to design a 4-bay window and then use it. That's what I like about Revit. But if you cannot design a 4-bay window, I've seen people who will pick a 2-bay window and then position it side by side. And then when you render it, it will look like a what? 4-bay window. Meanwhile, when you do a schedule of it, it will be two-bay windows. And the same way is applicable to truss. So the truss that we have here, for instance, if I go to load family here, and I go to trusses, what I'm saying is that from this thing truss, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Only 24 trusses are shipped with the software. So if you don't know how to design a truss, then what that means is that you will be compelled to use only these 24 trusses. There's no other design apart from these 24. So if you are a beginner, these 24 trusses might seem a lot of trusses. But if you are an advanced Revit user, then you want to do a project. Let's say, for instance, then you want to use a 3D truss. Do you know a 3D truss? A 3-dimensional truss. Whereby the truss is not just flat, but it's 3-dimensional in shape. And you want to use such a truss. And the architecture students that do a lot of thesis, when you are doing architectural thesis, and you want to showcase your work, and you want to show a 3D truss, then there is a way you can create a 3D truss. You did your conceptuals, you did the analysis, you did everything, and you told yourself that you are going to use a 3D truss. Meanwhile, if you come to the libraries, the trusses that is shipped with the software, all of them are 2-dimensional trusses, linear 2-dimensional trusses. So in that case, you'll be limited. But if you understand your way about, there is a concept in Revit called family components. And there's a family component environment whereby you can design any truss. So when you are using Revit, then you can design your own component. Let's take, for example, louver blades. We use a lot of louver blades in Ghana here. But I know so many Revit users that don't even have a louver blade in their libraries. And if you see them using a louver blade, and then you look at the detail of the louver blade that they are using, you will see that this louver blade is there. It doesn't look like a louver blade. But you still see people using it. If you look at the detail of it, it's not proper, but you still see people using it. But if you know what you are about, I am telling you on authority that you can design your own louver blade to the minutest detail. So let's position our mind that to be able to move from the essential level of Revit to the mastery level of Revit, what it means is that we must be able to be in a position to create our own custom 3D content. For instance, with this 2D, with this essential training that we are doing currently, I'm going to teach you how to create a custom 2D component, like how to create title blocks, how to create door tag, how to create room tag, how to create grid head, how to create level heads, how to create some of those things. It's 2-dimensional. That one is not difficult. I'll teach you. But if you want to create 3D components, that one will require mastery level of Revit training. And if you don't have a mastery level of Revit training, then you only have an essential understanding of Revit. You always be blaming Revit that Revit is limited. But please, Revit is not limited. If you want to push the Revit software, then you must push yourself and then be able to do things at the mastery level. Am I clear?
Yes, sir.
Thank you. Nico?
Yes, you are correct.
Nico, are you okay?
Yeah. Oh, I'm okay. I'm okay.
Thank you very much.
Now,
So,
I was thinking there's a way you can edit that, but I understand what you're
yes,
explaining.
this truss that we see here, you can edit it. You can edit it
Okay.
by changing the member at the top, the member at the bottom, the diagonal members, these vertical members. You can edit them, but still the nature and form will still look what the same.
Okay. I understand.
But only that you can edit the individual members. You can make them timber. You can make them hollow pipes. You can make them rectangular hollow pipes. You can make them circular hollow pipe. But the design of the truss will still remain what? The same. So if you want a different design that is not in the library, then in that case you must be able to design your own truss. And that level is a mastery level of Revit understanding. And we must pursue it. Nobody will push you to do it. No, if you don't pursue it yourself, nobody can compel you to do it. You as an individual must know that no, at this level of my understanding of Revit, I must push to that level. Nobody will push you to do it.
Thanks.
Thank you, sir. So that's all you need to know about truss. There's nothing more. So this truss, I can select it, change the distance, make it shorter. Do you understand? When I make it shorter, the design will still remain what? The same. When I make it longer, the design will still be what? The same. It doesn't change in any way. And that's a truss. So I can change it from this type to a different type. Let's say hollow gable truss. Now I can get this one. I can also change it from this one to another type. Hollow flat truss. Hollow flat truss. Then I can get this one. You can't do anything about it. But there are some few editing that you can do to it that we'll look at later on. But for now, I want you to know how you can create what? The truss. So if on this my building here, I know that I'm going to put a truss, then I'll draw a truss from here to here, draw a truss from here to here, draw a truss from here to here. So I'll just go to my roof level, for instance, here. I'll go to a roof level on this one. Then I'll pick my truss structure. Then I'll pick a truss. Then when I pick a truss, I'll draw it from this column here, then to terminate on this column here. Then that will be my truss drawn. Now the truss is drawn. Now when I change the detail level to medium or fine, I can see my truss. When I select it here, this way, and I select it, I know that I've selected what? A truss from the type properties. Then I can copy, CO, copy. So I'll copy from this grade, come to this grade, bring it to that grade, bring it to that grade, bring it to this grade, bring it to that grade. So it's the same truss I've copied. When I go to 3D view, I'll see that truss copied several times. As simple as that. Nothing more, nothing else. Are you okay?
Yes, yeah, okay.
Okay. Thank you very much. The next item I want to look at is a brace. A brace. Normally, when you put trusses on top of a building like this one, at times it will be very necessary for you to what? Brace them. So we add a diagonal brace maybe from here to there, and then from the bottom here to the top here, just to brace them. You understand? When you create columns like this one, then there's another column here, then you have a beam here and then a beam here. You can take a brace. Normally, brace are diagonal members that you draw across this way just to strengthen the object together. That's what we call what? A brace. So if you look at the image from here, you see that the brace, do you understand? They are diagonal members that you use in supporting what? Either a column, a beam, or what? Or trusses. So when I click on a brace is also a structural element, and it's also a linear element. I can activate 3D snapping. Then I say, I want to draw the brace, let's say from this corner here and then bring the brace to that corner here. And see, it will draw a brace across the building. I can draw another brace from this corner here, and then bring it to that corner here, and then to draw another brace. If I have a truss, I can draw a brace from the top here of the truss here, okay, and then bring it to the bottom here of the truss here, then to draw a brace there. Now I can also draw a brace, let's say from the top here, okay, and then bring it to the bottom here to get my brace here, then it will be added as a brace. So a brace is just a structural frame that you use in supporting members together. Normally when you look at church buildings and then they put trusses on top of the church buildings, you see that they will use galvanized pipe as braces to connect them and then weld them together. So basically that is a brace. And these are the structural elements that you need to know for now. As simple as that. Any question? Gary? Me?
Yeah, mankind.
Are you okay?
Mankind.
Yes, sir.
Mankind.
Yes, sir. Are you okay?
Let's see. I want to ask something.
Yes, okay, ask.
Yeah, you see the structure we have now is a simple structure, a rectangular structure. So if, let's say, we had an L-shaped or maybe a T-shaped structure, the joint between the roofs, if you want to put a truss there, the basic truss that you have in Revit, can it get you a truss to fit that joint, or all the trusses you can create in the simple trusses you can create in Revit come with this shape?
Let me illustrate what you are saying. Okay.
Yeah.
Let me illustrate that. I'll go to the ground floor.
Yeah.
I'll come to the side here. Let me pick just a wall. Start from here. Architectural wall. Start from here to there. Where's my wall not showing? Ground floor connected. Okay. There's a wall here. Why is our walls not showing? I'm coming. VV. Let me make sure walls are active. It's checked. Okay. Let me go to filters. Okay. Enable filter. Check none. Check none. Check none. Check none. These filters, I have to delete them so that the walls should now show. Let me go to 3D. Okay, let me take this wall for instance. I'm coming. Create similar. Okay. Then start from here.
Okay.
Come here. Go there. Go here. Go this way. And then join this one. Okay. Do you see what I see?
Yes.
And I want to put a truss on top.
Yeah.
So I can go to structure, go to truss. Okay. Then with the truss, I can start from say here. Okay. And then draw it all the way toward here.
Okay.
Now where is my truss? It's here. Okay. Now the truss is at the foundation level. Let me select this walls before. Make sure that the walls is terminating on the roof level. Now let me take this truss. Go to edit wet plane. And then make sure that it is on the roof level. Go to OK. So this truss is here. I can select it, create similar. Okay. And I want it to be on the not at the foundation level, but I want it on the roof level. So I can draw another truss from this corner here to come here. I can draw another truss from this corner here to go there. I can draw another truss from this corner here also to go and meet here. Okay, let's have another one here. I can better still draw another truss from this corner here to go and meet this corner also here. So this is also another truss. So if you look at it, they are all linear elements, and I've placed them in different locations, and they are all just linear elements. The only thing I can do with these trusses is that the design of this truss can be different from the design of this truss. The design of this truss can be different from the design of this truss, and the design of this truss can be different from the design of this truss. But for now, what is concerning me now is how to create the truss. Later on, I'll show you how to edit the truss so that it can be more useful than currently it is.
Okay.
Is your question answered?
Yeah, I'm fine.
Okay. Any other issue? Now, the next thing I want to look at is foundations. If you want to create foundations, we have isolated foundation, we have wall foundation. Right now, I'll do both to show you. When we take a wall foundation is attached to a what? To a wall. As simple as that. So, and when you take an isolated foundation is attached to a what? A column. Okay? So, if you want to put the foundation part behind this column, then you can use an isolated foundation. If you want to put a straight foundation beneath this wall, then use a wall foundation. So you just take wall foundation. As soon as you take wall foundation, you just select your wall, and then the foundation is added. You select this wall, foundation is added. You select that wall, foundation is added. You select that wall, foundation is added. You select that wall, all of them, then to add the foundation wall. The only thing that should concern you is that this foundation, what is the width, what is the height, and what is the depth. And you can always edit it to get it properly sized. So when you create a foundation, the only thing that should concern you is how you can size the foundation so that it can be, say, 450 mm by 225 by, let's say, whatever length you wanted. Are you okay? As simple as that. Then when it comes to the isolated column like this one, you can also add foundation to isolated columns. So you go to isolated foundation. As soon as you click on the column, you can always place it, or you can place it at what? At columns. So if you say at columns, and then select the column, then to be added. You select a column, then to be added. If you select a column, then to be added. That's how simple it is. If you want to do multiple, you can do multiple. But when you are also placing the foundation, you must define the level on which you want the foundation to be to be placed. So if I want the foundation on the foundation level, I'll click here, then to be added to the foundation level, finish. Then my foundation is created. If I come in here, I want it on the foundation level, you can place it at column. You select the column, I want it at the foundation level, then you click on it, sharp, then the foundation will be created, then you choose what, finish. If you want to do multiple selection, you can go to add grades, you can go to add columns. So if you go to add columns, you can select all the columns. So I can go to the right here, and then these columns are the right here. I'll select all of them at columns. As soon as I select all of them at columns, then I go to finish, then to be placed at the what? At the columns where I want them to be placed. As simple as that. When you draw them finish and then you are done, you can always select it and then change the level on which it is, either to a foundation level or to a roof level or to whatever level that you want to move it to. As simple as that. So basically those are the foundations. Any question? Any question?
No, sir.
Thank you.
Sorry to disturb, but can you go over the footing for me a little bit?
I should go by the footing again. Okay,
Yes,
let's begin
please.
this one. Select all instances in entire project. Delete. I'm saying that there are two types, or let's say three types, but for now, let's discuss these two first. Where's the magnifier? For now, let's discuss isolated and then the wall. We will look at the slab later on, okay? But let's look at isolated. The isolated foundation is related to a column. Normally, we put it at the base of a what? A column. A column foundation, a column footing. Then we have wall foundation, which is a strip that follows the length of a wall. But when you are creating it, you must be concerned with the length and then the depth of the foundation. So when I click on this foundation here and I go to the properties, it is a wall foundation bearing footing 900 by what? 300. So if I come in here and then I click on this wall, it will automatically create a foundation, and the distance from here to here is 900, and the distance from here to here is what? 300. You can create different sizes. You can select this foundation, edit type. Like say you can go to edit type, and when you go to edit, if not look at edit type, you can come in here and then change the width. You can come in here and then change the what? Thickness. But for now, I'm just maintaining the dimensions that is what? That is already there, which is 900 by 300. And anytime you click on any wall, the foundation will be automatically placed at the bottom of the what? Of the wall. So when I go to this foundation and then I right click and I say create similar, I'll select this wall, then it will be created. Select that wall, it will be created. Select that wall, it will be created. Select that wall, it will be created. I can even select multiple. If I go to multiple, then I'll select a multiple walls. Then automatically, when I choose finish, then the foundation will be what? Will be created. As simple as that. Are we okay?
Thank you, yes.
Then the second one is the isolated foundation. The isolated one. That one we apply to columns. When you have a column, you can always place a foundation at the bottom of that column or at the top of that column where it is appropriate for you to place the foundation. So if I select this foundation, for instance, go to modify, select this foundation, right click, select all instances in the entire project, then I'm going to delete it. When I delete it and I want to add a foundation, I can add isolated foundation to this footing, to that footing, to that footing, to that footing. So I'll go in and then choose foundation isolated. And when I click on it, I can click anywhere and place it. It's a foundation, I can click here and place it. But ideally, we don't just place foundations anywhere. We place it at the base of what? Columns. So I can go to add column. And when I go to add column, anytime I select a column, it will place it. But before I place it, I must define the level on which I want it. I want it on the foundation level. So if I click here, it will be placed at the what? Foundation level. This one will be placed at the what? Foundation level. When I finish, it will be placed. If you want to do multiple selection, you can do that. But if I want to do at columns, I can do it manually. Click this one. No, not at the ground, but I want it at the foundation level. You click this one, bingo, then to create the foundation for you. As simple as that. Then you choose finish. But the only thing that should concern you is that, can you edit this foundation? Can you size it properly? Can you make it to work? As simple as that.
Thank you.
Any further question? If there is no question, when we come to tomorrow's class, I am going to open the previous project let's say lesson 6, the one we worked on. This project, then I'm going to add columns at appropriate places. I'm going to add the foundation footing. I'm going to add trusses. I'm going to add beams. I'm going to add columns. I'm going to add ceiling joists for the ceiling. And everything that is structural. When we meet tomorrow, I'm going to model it in this one. I expect you also to go and model it in your what? In your project. Are you okay? Are you okay?
Yeah, I'm.
Yes, sir.
Yeah.
But
Yes, sir.
But let me also state something. In a typical practice, in a typical workflow, architectural drawings are totally different from what? Structural what? Drawings. Do you agree on that? Normally, when we are producing a set of
I agree.
drawings, when we are producing a set of drawings, we produce different set of architectural drawings. Then we produce different set of what? Structural what? Drawings. But because I'm teaching, I'll be combining architectural drawings and structural drawings together. But in the medium term, we are going to separate the architectural drawings from the what? Structural what? Drawings. So that when you open a structural drawing, you know that you are only doing structures. When you open architectural drawings, you are only doing architectural drawings. When you are doing a site, it's only a site drawing. So we will be working with multiple files, each one dedicated to a specific word, discipline. Are you okay? Do you realize that it didn't take us a long time to learn structures? Do you realize it?
Yes, sir.
It's not difficult. But what we'll be looking at later on is how to edit them so that you can size your columns properly. If you want to do a concrete column, you know how to do a concrete column. If you want to do a concrete beam, you know how to do a concrete beam. If you want to create a wooden joist, you should know how to create a wooden joist. Let me do an illustration here so that you appreciate what I'm trying to say. Maybe I want to add a ceiling joist to this ceiling in the living room area here. Assuming I want to add a ceiling joist here. What do I need to know about the ceiling joist before I create them? One, I must know the sizes of the members that I want to use, and then the type of member I want to use. In this case, I want to use a wooden member for the ceiling joist. After knowing the ceiling member, I must know the size of the ceiling wall member. Then 3, I must know the spacing of the ceiling wall members. So this is what I'm going to do right now. So to do that, I need a wooden member, a wooden structural member that I can use to create my ceiling member here. So first, I need to make sure that that wooden member is loaded. So I'll go to 1, insert, load family. Make sure I'm in my metric library English. I'm in the UK folder, I'm in UK folder. Then I'll go to structural framing. We call it structural framing. Where is it? We have structural connections, foundation, structural framing. So I'll go to structural framing. When we go to structural framing, we have concrete frame, large gauge steel, precast concrete, steel, truss members, wood. I want wood, so I'll choose wood. Then within the wood, we have dimensioned lumber. We have dimensioned lumber. We also have glulam 1, glulam 2, laminated veneer lumber, plywood web joist, normal timber, and then wood open web joist. So I'll pick a normal timber. Then I'll click open. There are predefined sizes. I won't pick any of them. I'll just pick the normal timber, then go to OK. So currently, that timber is loaded. So if I go to structures, and I go to beam, I can see timber member loaded 140 by 140, 190 by 20. So if I draw it here, for instance, I'll see my timber member here. This is it. But currently, the size that is here, I'm not comfortable with the size. So I need to create a different size for this member. To create a different size means that I need to create a different type. So I'll go to edit type. Then a dialog box will pop up here. Then 140 by 140, I don't want that one. I want to create a duplicate. And because I'm going to do a ceiling, I want 50 by 50 members. So I'll do 50 by 50 mm for the size. Then I'll go to OK. I'll make sure that the width is 50. And then the depth is also what? 50. Then I'll go to OK. So when I do that, this is 50 by 50 timber member that I've created. So I have the timber member already created. Now, if I want to create a ceiling member here, ceiling joist or whatever here, I need to know how I want the ceiling members to be spaced. In this case, I'm going to do 600 by 600 spacing. So I'll go to system, beam system. Then the beam system, I want to draw the boundary rectangle. Now the rectangle, I can draw it. I want to set where I want to draw it. The work plane, I want to set it. This time round, I want to pick a plane, not a level, because I want to do it on the ceiling. So I can pick a plane, then go to OK here, then come in here, and then pick this plane on top of the ceiling. Now when I finish that, I can draw a rectangle from this corner here, and then bring it all the way to this also corner here. You see, I can check it to make sure that it's at the right corner. Good. So it didn't get to the corner I expected it to be. So I can select it, drag it to meet this line. Select this one to drag it to meet this line. To be very sure, I can go to the ground floor reflected ceiling and then check. It is starting from this corner here all the way to this corner here. That's how I want my ceiling members to be. The distance, I want to have a fixed distance. And then the fixed distance here, I want the spacing between them to be what? 600. So I'll choose 600. When I'm done, then I choose finish here. It is going to create ceiling members at 600 centers. If I go to the 3D view, I'll see them. This is a different project. I think it's here. You see? Do you see it? So this one is 600 by 600 members. Currently, it is lying on the level, so I cannot see very clearly. So I'll go to the properties, elevation from level, let me make it about 50. If I make it 50, then to come above it, 50 above the ceiling. But the sizing is not the 51. So I'll go to the properties and then check that the beam type is not 140 by 140, but rather it's supposed to be the timber 50 by 50. Now when I come here, I see them 50 by 50 members drawn on my ceiling. I have the horizontal members. So I can select the beam system again, make a duplicate copy of it, copy, paste, align to same place. So it is pasted at the same place. Then I'll just choose edit boundary. And when I choose edit boundary, instead of it going horizontal this way, I'll change the beam direction and then pick here on this direction. So I have to go vertical this way. When I finish, I'll get my timber members created at 600 by 600 center. And I am done. As simple as that. If I want to do for this space, I'll do the same thing. If I want to do for this space, I'll do the same thing. When I go to my section, so I'll go to the ground floor plan here and then take one of the sections that goes to the space and then look at it. In section view, I should be able to see my members properly drawn. The only problem with it right now is that in terms of drafting, graphical representation, they are not well drafted, but the model is properly done, whereby I can see my members here and I can see my members here. If I go to this section 2, I can see my ceiling members in section. As simple as that. Any question?
Yeah, please, I'm going to go over the vertical and everything.
What I'm saying is that anytime you are creating a beam system, you can only get one direction. Only one beam direction. Only one. It can be two. It's just one. So, and if you are creating these structural members, these ceiling members here, you need a grade of vertical and then horizontal members to be able to complete them. You understand? So you do the first beam member, give it a direction. When you finish, you make a copy of it. Then you edit that one and then change the word direction. So for instance, if I want to add another ceiling here, in this space here, I'll go to ground floor reflected ceiling. And I want to do my ceiling in this space here. This is the normal ceiling that I did. But I now want to add a ceiling word member. The ceiling member. So I'll go in and then choose structure. Then choose beam system. We use the beam system to create a repetitive structural element. In this case, for ceiling joists. So I'll pick beam system. Then within the beam system, I'll choose a work plane. You need to define a work plane that you want to work with. So before then, I'll go and set a work plane. You come to the right here, work plane, set. I want to pick a plane. So that plane, I'll pick this plane here. That's where I want to work. So that's the plane. Then I can go in and then choose beam system. And when I choose a beam system, the work plane of this view cannot be used to create a beam system using the one-click creation tool. Okay, perform it in another view. Okay, let me go to set. Set a work plane. For instance, for now, let me put it on, let's say, roof level for now. I can change it later on. I'll pick it on roof level, then go to OK. So that's the roof level work plane. Then I can choose rectangle and then draw from this corner here to that corner here. Now, currently, where this double bar is, shows that the members will be arranged in this direction, depending upon how I am spacing it. If I want to change the direction, maybe I want to do diagonal members, I can go to the beam direction here, and then within the beam direction, I can draw maybe from this corner here to that corner here. In that case, this will be the direction of my what? Of my members. So it will be offsetted from this one in this direction. And I will come in and specify the distance between them, 600 by 600. When I finish, bingo, it will create my system. If I go to the 3D view here, if I open the 3D view, I'll see my ceiling members. Where is it? Oh, it's here. Yes, hide in view. Let me hide this roof in view. Elements. This is why I do the member. So that it has been given in a diagonal direction. Now, if I don't want it in the diagonal direction, I'll select this beam system, edit the boundary, then the beam direction, I can say I want it along this edge. So it will be here. When I'm finished, this will be the direction of the beam direction here, as you can see. But the beam members is not reflecting what I want. So I'll select the beam system, go to the properties, and then the beam type I want to use. I want to use the 50 by what? 50 beam. So I'll choose that one. And when I come back, I'll get the 50 by 50. Please, are you okay up to this point?
Yes, please. Thank you.
So now I've gotten the beam in only what? One what? Direction. I need the cross members also in another direction. So what I'll do is that instead of me drawing another beam, I can just take this beam, copy it to clipboard. Do you understand? When it is copied, I'll go to paste, align to same place, so to make a duplicate copy. And while it is still selected, I'll go to edit boundary. And when I choose edit boundary, instead of beam direction going here, I want the beam direction to be in the opposite direction this way. So this will be the direction for the members. When I finish, I have my vertical and the horizontal members, and I have my ceiling members design. These ceiling members, I can bring it up or I can bring it low by changing the base offset or elevation from the level. Then my beam members are there. As simple as that. So I can do for this room, do for that room, do for that room, and anytime I go to my ground floor plan or roof plan and I want to take a section through the building, when I take a section, I'll see my members here, then I'll see my members here also. You see that the position of these members and then the position of these members are not the same. You can just select it and then editing the properties here, you can bring it above or below. If I say it should come down negative 300, then it will come down by negative 300, as you can see. If I select this one that I want this one to come down negative 300, I'll come here and then give it negative 300, then to come down negative 300. You are not restricted by anything. As simple as that. Any question?
Okay, so everything lies on the direction you give.
The direction you give it to it. Thank you.
Okay.
And
then when you try to move it in section, it doesn't move the ceiling.
No, it doesn't move the ceiling. It is independent of the ceiling. Unless you decide to constrain it to the ceiling, which you can do. So I can use this alignment tool here, modify. There's alignment tool. When I choose alignment, I can select the face of the ceiling. Then I can come and select the ceiling member. And then I'll align it. And when I align it, I can lock it. So that when the ceiling moves, it will move with it. Or as of the time that I'm creating it, I can decide that I want to use the ceiling member as a work plane, whereby I want to place my ceiling beam system.
I understand. Thanks.
Please, let me emphasize here. What I'm teaching you now is very conceptual. It is not realistic. It will only become realistic when you use it on a real project. And when you use it on a real project, the issues will come, then you address them. So when we meet tomorrow, I'll take my time. All the things that we've learned under structures, I'll open this model again. Okay? Then you add the columns, we will add the foundation footings, we will add all the ceilings, we will add beams and everything, and then make it complete. And by the time we finish, I think everybody should be okay. So that the project that you are also working on, you can go and practice it on the project. And when you have questions, when we meet on Thursday, you can bring those questions, then I'll answer them for you. If I finish teaching, then you assume that, oh, the thing is simple, it's not difficult, you understand it. Then you go and you don't practice it. Please, I beg, you can forget. You can easily forget. Practice, they say, makes man perfect. So please, I beg of you, anything small that we learn here, make time and practice. When you have issues, bring it up then let's help you solve the problem. Thank you, ladies and gentlemen. If you have a question, you can bring it up again.
Yeah, thank you, Wankan. Thanks for taking us through this. I joined late, but I've learned a lot. Now, my question is that this one appears to be on a flat plane. What if you have an inclined ceiling?
Yes. Anytime
If you
you
have
are
an
drawn,
inclined ceiling,
you
in the bigger box, you have an
let me
inclined
use the
ceiling.
roof, for instance. This roof. So let me take this roof and then unhide it. So let's say maybe you want to put some rafters under this roof. Are you okay? Does this serve the purpose of the question you're asking? Are you okay with this scenario? Okay. So in that same way, we go to structure, beam system. So you activate the beam system. The most important thing you need to define is the work plane that you want to create it. So you go to work plane and then go to set work plane. Set work plane. Or you can pick a plane. You understand? So for now, let me just choose pick a plane. So I'll choose pick a plane. So I'll come in. I want it below here. You see, I can pick the top plane here. You understand? I can pick the bottom plane. I can pick the face here. But I want it at the bottom here, so I'll pick here. When I pick here, that is the active word, active plane. Now I can take my rectangle, start from this corner here on the active plane, move all the way down to this lower left corner here on the active plane. So you see that the rectangle that I drew was drawn on the particular word, plane. You see? You see it? So the beam system that I'm drawing is drawn relative to that plane. When I finish drawing, then I'll choose finish. So I'll go to finish. And when I choose finish, my beams will be created under it, as you can see. Let me go to VV and then make the roof transparent. So I'll go to roof whilst I'm working, roofs, and then under roof transparency, override. I'll click on the override, then make it transparent, about 80% transparent. Go to OK, go to OK. You see my members under the roof. So I can now select my beam system, which is under the roof here. So I'll go and select the beam system and then change the beam member I want to use. In this case, this is supposed to be a rafter. So the spacing between them is not supposed to be 600, but the spacing between them can be 1050. 10540. That's the first thing. Two, the members, which are rafters also, I must define the proper dimensions for them. So I can take this one of the beam members, go to edit type, duplicate it. When I make a duplicate it, I can give it a dimension. Let's say 50 by 150 mm for the rafter. So that here the D will be 50 and then the D will be what? 150. Okay, then I'll go to OK. Now when I finish and I select my beam system here, which I've created, if I hover over it, I'll see the beam system at the edge. So I'll select the beam system, which I use. I'll select that one. Then come to the member, change it to 50 by 150. Then I'll get my rafters. As simple as that. I can give it an offset relative to the plane. I can do that. If I need my purlins, I can define different sizes for my purlins, set that plane, and then draw it on that plane. And by the time I'm done, I have my members there. So that when I go back to my sections, and then on the ground floor here, and I open one of the sections, let's say this particular section here. When I open it, I should see my, it's not this section rather, but let's say this one. I should see my beam, the rafter members what added, and I can give them offset and I can do anything to them. Is your question answered?
Yes, sir. Thank you.
Thank you, boss. Please, any further question? Tomorrow, when we come, we are going to apply all what we've learned structurally on these projects. So we will add footings, we will add columns, we will add beams, ceiling joists, ceiling members, rafters, purlins, ridge piece, everything. Fascia, you do that. And even the roof member, I want us to start we've now created a lot of members, so tomorrow we'll start editing some of the elements like we edited the walls. So we'll edit the roof members, we'll edit the purlins, we'll edit the rafters, we'll edit the roofing members so that we can size them properly, so that our building will begin to look as realistic as possible. Thank you, sirs. Thank you, ladies and gentlemen. If there are no further questions, I suggest we close here.
Thank you.
Thank you, sir.
You're welcome.
Thank you, sir.
Thank you, sir. But please make time and practice, because the more you practice, the better you become. If you don't practice, you can forget to please. And if you practice, you can bring real questions for it to be answered for you. Okay? So thank you, Nico. Thank you, Pakofi, PC, Gary, Benjamin, Dixon, Eyima, Gary, and then Nee. Thank you, all of you. Nee,
Yeah, okay. Thank you.
Nee,
Thank you, sir.
Mr. Nee. Hello, Nee.
Yes, sir.
Today you are quiet, pa. Why?
Well, from tomorrow I'll say something because let's make it from tomorrow,
I hear
please.
you. Everybody enjoy your
Thank
evening.
you.
Thank you, sir. Bye-bye.
Bye.